Okay, so this is from the homework packet, chapter 3 from calculus number 39. And it's talking about putting a can of soda in a cold fridge. And you need to sketch a graph of what the temperature of the soda might be. So let's look at this. So if the temperature was warm at first, it's going to have, some sort of temperature. Whoop. It's going to cool off. So we're going to start it at a higher temperature and then have it cool off. Now, I don't know what the physics-related actual curves look like, but you do know that whatever it started at, it's going to cool down. So maybe it cools down something like this. I don't actually know if it goes like that, or maybe it's linear. Maybe it's sort of like a decay type function. Or not that one. That would be this one instead. So, but whatever it is, it's going to be decreasing. And then it'll taper off at some point because it's not going to go forever down like this. So it'll reach some coolest temperature. So at some point, they all have to taper off. So let's see. T is measured in degrees Fahrenheit. And, oh, sorry, that's big T. And little t is measured in minutes. So then one of the questions is, what are the units of t prime of t? And this might be easier to see as d big T over d little t. So the units of capital T are degrees Fahrenheit, and the units of little t are minutes. So really, the units of t prime are going to be degrees Fahrenheit per minute. Now, if it says you know that t prime 45 equals negative 1.2, then that means, now little t is 45 here. So that means after 45 minutes, or 45, let's say this, 45 minutes after placing the soda can in the fridge, the temperature is changing at a rate, because remember this is about a rate, at a rate of negative 1.2 degrees Fahrenheit per minute. Since it's negative, that actually means it's cooling off. If it was positive, then it'd be getting hotter, which wouldn't make sense in a fridge, probably, unless you threw something way cold into the fridge. And that's the rest of the question. It says, besides representing the slope on the graph of t, because you could also say, if this is 45 right here, right there, the slope is negative 1.2. But that's just like a pure graphical way of looking at it. This is the important idea here. What does it really mean? Okay.